Hi, welcome to this SimplyMaya tutorial. In this tutorial we're going to be walking you through the process of interior illumination in Maya. We're going to be using physically accurate illumination and we're going to be working with this scene here. But the ultimate goal of this tutorial is not to teach you how to light up one scene, it's to teach you how to light up any interior with Maya's physically accurate lighting tools. Now, at the heart of this process is something called linear workflow, which you've probably heard mentioned. It's been bandied around in the 3D community for quite a while now. Now I'm going to demonstrate to you why we need to use this during the course of this tutorial, and why you should be using it for your own interiors and exteriors too. I'm going to attempt to do this without a lot of complicated graphs and math, and hopefully you won't fall asleep while watching it. But just to show you why we need it, this is a quick test render taken partially through the tutorial using linear workflow. This is what this would look like if we hadn't used a linear workflow. So as you can see, there's quite a dramatic difference in these two images. This is with the correct workflow, this is with standard Maya workflow out of the box. Now I'm going to demonstrate this to you in as simplest terms as possible. So if I just create here a quick ground plane, okay, and I'm just going to introduce an area light because they have natural decay. So I'm going to create lights, area light, okay, there we go, and I'll just move it back and up a bit and scale it. Okay, if I take a quick render here, and we're going to be using mental ray throughout this tutorial. So if I render this, what you'll see is a very dark image, and if I actually move this thing closer, you'll start to see a large white hotspot. So we've got a very dark image with a very bright hotspot here. Now I've seen many ways of dealing with this. People have a tendency to move their area light back a bit to get rid of the hotspot, and then crank up the intensity to say 10. The problem with this is now our hotspot got even bigger, but we are introducing light into the scene. So what tends to happen is you move your lights further and further back, you use insane intensity values going up into the tens of thousands sometimes, and this makes your whole process of lighting a lot more complicated than it needs to be. So we're going to achieve what we call a linear workflow. And basically, for our intents and purposes, what this means is this image in Maya has not been gamma corrected yet. So what you're actually looking at here is a linear image with no gamma on it. Now every other image you'll see on your PC pretty much has been gamma corrected. So if you take a picture on your digital camera, if you open a picture download a picture from the internet, chances are that it'll have gamma applied to it. And I want to show you what happens to this image when we apply gamma. So there's a few ways to do this. The way I like to use is with a mental ray camera node. So if we select our camera, and before I do that I'm actually going to create another camera. I find it's a much better idea to work with a custom camera than the inbuilt perspective node. I like to leave the inbuilt perspective camera at its default. So I'm going to go up to create cameras, camera, okay, and then I'm just going to hit perspective camera 1, and now we have our own camera to work with, and this will leave us the default perspective camera alone. So again, I'll just take a render from here. Actually that's still rendering out the perspective, so we'll render for camera 1, and I'll keep that. And now I'm going to show you what happens when we activate a correct workflow. So I'm selecting my camera, scrolling down to mental ray, under lens shaders, hit the checkbox, under lenses I'm going to use a simple exposure node, and you'll see immediately that it brings up the simple exposure node's preferences, and it's got a gamma of 2.2. So if I now render this again, you'll see that our scene is much brighter, and in fact even if I turn the intensity of this light down to 1 and hit render, you'll see I've got a much better fall off of the way the light pattern falls. I don't have a huge hotspot here, and I haven't had to use huge values in my intensity. Now This is because Maya works, all its math for its lights are worked out in linear. This image by default is linear, so it has no gamma correction applied to it, so you're not actually seeing the true image that's been generated for display on a monitor. You're seeing an image that's been generated more for display in a compositing package, which is fine. But in order for us to, be able to see what our render should truly look like, you need to drop in this simple exposure node. You can also do this with a photographic exposure node if you want more control, but for our intents and purposes this will do fine. Now I'm going to just kill this off here, and I'm going to import our basic room proxy shape. Now I've exported everything for this tutorial in both Maya format and object, as I'm using Maya 2013. If you're using an earlier version and you have problems opening my scene files, there's objects available for you too, so you should have no problem following along. So I'm going to open my room proxy, and one of the first things you'll notice is it's huge. This is because when you're working with physically accurate lighting, I'll just center this pivot point. When you're working with physically accurate lighting in Maya, scale becomes very important. If you think about it yourself, a 40-watt light bulb is going to behave very differently in a broom cupboard than it would if you stuck it in a football stadium. So in order to get a realistic lighting scenario in Maya, to get the best out of it at least, we work in scale. So in this case our hallway is about 13 meters long, and to get my grid back to the proper proportions, I'm going to go up to my settings, just hit settings here and change this from centimeter to meter. That's safe. You can work in feet and inches if you're more comfortable with that. Just remember that you are building to scale. Okay, now I'll select my now tiny area light, and I'm just going to move it in front of our doorway so I can show you another example of why this linear workflow becomes so important when you're working with, and I'll just flick this round. On an area light you probably already know, but this is the direction of the light, so I'm going to just rotate that around X 180 degrees. Bang, so it's actually shining in the room. I'm going to put the camera in the room. There we go. Okay, and because our room is a little short here, I'm going to change my camera lens over from the standard 35mm to a 28mm. There you go. And if I take a render of this now, this is the room with a correct gamma applied to the rendered image. So as you can see, we have a small hotspot here around the door, we have this nice progression of light pattern, and already we have what appears to be a bright light outside shining in. Now if I just take a snapshot of that and I go to my camera and remove our lens shader here, so now basically we've gone from this image, which will be properly gamma corrected, to an image that will not. And as you can see, without activating our linear workflow here, we're going to see a dramatic change. We're going to have to radically adjust how we do our lighting. So this is why it becomes very important to use this lens shader and get the correct gamma on the rendered image. Now I'll just put that gamma back in, so go to my hypershade here, and you can find your exposure node under hypershade utilities, middle mouse drag it back, and it should be set back on there. So we should go from this back to there. Okay, there is another advantage with using the exposure node. Not only do we get the correct gamma on our rendered images, we also have more control over our images. So the pedestal in this case will control the black levels. So if I put the pedestal to 0.1, you'll see all our blacks go to a much lighter color. So without doing anything to our lights, we already get a much greater degree of control over our whole lighting scenario without having to really adjust any of the lights. Now the gain can be thought of as the overall brightness adjuster. So if I put the gain to say 2, you'll see this whole image goes a bit brighter. So there you go. Again, we have this huge degree of control without actually adjusting our lights. So I'll put this back down to its default. Now the knee is the point at which an overly bright image is squashed. So if I can up the intensity value on this light a bit to say 4, I'll get a much bigger hotspot around the doorway. So as you can see, we now have a hugely overexposed image. Now obviously this is not a great scenario, but if you want a quick fix, if I turn the knee say down to 0.1, you should see a lot of this hotspot start to go away. So the knee can be used to squash overly bright values in an image. This is not the best way to do it, but it can be done this way. Now the compression works very closely with the knee, and this is how much they will be squashed by. And I'll show you a better example of this later on down the road, because it's actually quite tricky to see on such a simple image. Gamma. Now it's 2.2 by default. This is a standard gamma setting for a normal monitor. But if you wanted to say a slightly more, let me just put this knee back to its default 0.5 and do a render so you can see what happens with the gamma. If you wanted a slightly darker, say moodier image, you can then use the gamma for this. So let's get a render. That's our standard render. If you wanted to make this just a little darker, give it a little more atmosphere, you could use the gamma down to 1.8 maybe, and if we hit render, you'll see that it went just a little bit darker. Our fall off is a little bit more pronounced. So again, without even touching Maya's lights, without adding a lot of unnecessary lights to the scene, we gain a great deal of control. Now preview is used, the preview here is used when you have a more complicated image and you want to tweak these values without having to re-render the entire image, and I'm going to show you that in just a sec. But before we get to that, I want to show you one of the downsides of working with this type of setup. Now if you've ever played with Maya's physical sun and sky, you'll find that one of these exposure nodes is created by default, and this is what happens to a lot of people. I'm going to just create a sphere here. Okay, so I have my sphere. In fact, I'm going to do this outside the confines of our little proxy object here, just to give you a better view. Okay, and I'm just going to apply a new material to this. Just a standard Lambert will be fine, and I'm going to add a texture to it. So in this case, I'll just use the wooden floorboard texture that we'll probably be using in the tutorial, and I'll open that up. And you see here in the viewport, this is a fine looking wooden standard sort of floorboard texture. Now if I was to take a render of this, you'll see it's extremely white and washed out. If I break the connection between our camera lens shader, between our exposure control, and render it again, you'll see that this is what it looks like. So the problem most people have when they dive into a linear workflow is they get these washed out, kind of horrible looking textures, and it's very easy to fix. If I just open up my hypershade again and drag my lens shader into here, oops, there we go. So just middle mouse drag my exposure simple node back down to my lens shader, and you'll see we get this very nasty washed out texture. This is because now your render view is being gamma corrected to the gamma value generally of 2.2. The problem is your texture has already been gamma corrected. So there's a gamma of probably 2.2 applied to this, and then once again 2.2 applied to this. So Maya expects these textures in this particular linear type workflow to be gamma neutral. So we need to now go and make this gamma neutral, which I'm going to do by just graphing my Lambert texture here, my Lambert shader, and you'll see here that this is our file. It's connected to the color. What we need to do is find a way of telling this file that it doesn't actually have gamma, so we need to remove the gamma before we go on to the render. So if I just look here under my utilities for the gamma connection node, I'm going to actually break the connection between the file texture and the shader. I'm then going to middle mouse drag the texture file over to the gamma value, and I'm going to middle mouse drag the gamma itself over to the color. So as you'll see, our texture is back, and all we've actually done is we have simply stuck this gamma correct node between the file and the shader here. So if we render again, you'll see that nothing has happened because this still has the gamma applied. Just applying this node won't automatically take it off. You have to apply a reverse gamma value of 0.454 on the red, green and blue channels here. And you'll see now that when we render, our texture has come back to life. It looks as it should. Now there is another way of achieving a similar effect. I prefer to gamma correct my textures as they come in, and you will find various scripts on the internet that will do this automatically if you have thousands upon thousands of textures. So if I just get rid of this, so we have no gamma correction node now, and I'm just going to drag the texture over to the color here and render, you'll obviously see that washed out texture. If we go into our render settings and enable color management, this is going to tell Maya that all the textures we bring in are sRGB and need gamma correcting. So just by ticking this box, I will then get the correct texture. Now this is not my preferred way to do it. It is quite a quick nasty cheat. It doesn't have the advantages of doing it correctly, but if you do just want a quick preview, it's not a bad option for you. So I'm going to turn that off, and just to take you through the process of connecting this gamma node again, just to show you that it is quite quick and simple. Throw in a gamma node, simply drag up the texture into the value, select the Lambert, middle mouse drag over to color, reverse gamma correct 0.454, do this 3 times, and there's your gamma correction node. It's really not that difficult or complicated once you've done it a few times. So the problem is, though, we have now a gamma corrected image in our viewport, which is obviously a lot darker than it appears on our render view. If you're lucky enough to use viewport 2, we can activate it now, and you'll see this is still too dark. If you open up the settings for viewport 2, however, you will find a gamma correction, and there it's the standard 2.2. So now you'll see here in viewport 2 what you'll see in your render. So this process, once you work it out, the advantages are extremely numerous. The disadvantages are basically you have to watch the gamma on your incoming images within Maya. Now I am going to just show you one last thing, which is the preview option on the simple exposure. And to do this, I'm just going to load in our room scene from about 3/4 of the way through the tutorial. Okay, I've just loaded in the room scene from part of the way through the tutorial, and I'm going to show you here we of course have under our mental ray in the camera, we of course have a simple exposure node on here, and I'm going to show you now how to use this preview function. And the reason I've loaded in our scene is that preview allows you to quickly tweak a render that would take a long time, and our previous test renders have been about 1 second, so it's kind of difficult to see the difference with the preview. So first things first, in order to use this preview you need to have previously rendered out HDR image, EXR or HDR format, or any other HDR supporting 32-bit file format, which I have done for us. So if I just drop into images here, you see I've got an EXR already loaded in. So once you've loaded in your EXR, click Use Preview, go up to your render settings, and under Features turn off all of your indirect illumination options. Okay, what this will do for us is allow us to preview these settings without re-rendering the whole entire frame. So if I click Render now, this is normally about a 15-minute render, but you should see this comes in probably about 10 seconds. Okay, and now I can start to tweak again my exposure node. So if I put the gamma here to 1.8, you'll see that I don't need to re-render. It's not a 15-minute render every time I do this. So not only does this become extremely flexible, give you a much greater degree of control over your lighting. Using this workflow means you won't have to pump your lights up to insane values. It also gives you a very high degree of control over the finished rendered image. Just, you know, waiting 15 seconds, 10 seconds, a very short time for you to see how this would work. You can also, with this, if you wanted to go to the more advanced exposure node, the photographic exposure node, you can just drop this in, and using the same preview in that options, you'll be able to then change between different exposure nodes without having to re-render your entire frame. And we can get a much better look now at what some of these values do. So if I was to put this down to say minus 0.07, and a little value on the pedestal goes a long way, I find. So I'll just screen grab this. You'll see my blacks get a lot more intense now. Okay, so you can start to see here that the corner of the room has gone a lot darker. This shadow out here has gone almost pitch black. So that was the introduction and a linear workflow and why we'll be using it. I hope you found that of interest, and I'll be back in the next part when we discuss sun and sky. I will see you then. Thanks for watching. Hi, welcome back. In this part we're just going to cover physical sun and sky, which is an integral part of our lighting scheme. So we're going to start off by again importing our proxy object. And I'm using this proxy object simply because it will render a lot faster and we won't all have to die of boredom while waiting for the render to finish. So here is our proxy object, and once again you'll notice that my grid has been set to centimeters. So I'm just going to go up to our preferences and set it to meters. Okay, and again you can work in feet if you'd rather, doesn't really matter, just needs to be accurately to scale. So I'm going to move our room here. Okay, so that's our basic proxy object imported. Now there's a few ways to link up physical sun and sky. You'll be glad to know I'm going to go with the simplest one. So mental ray, make sure you're under render settings and render using mental ray, which we'll be using throughout this tutorial. Indirect lighting, physical sun and sky, create. Now I'm going to open up the hypershade to show you what this has actually done, because it's nice that it just creates it automatically, but I find it very helpful within Maya to actually see what has happened. So if I look under utilities, you'll see that it's automatically created the simple exposure node for us. It's created a physical sky and a physical sun, and if I graph the network of this physical sun, you'll see that the physical sun is connected to the physical sky, which is connected to a sun shape, which I'll show you in the display. Here it's just a directional light. It's important to note that this directional light is actually controlled through this node here, which is again controlled through this node here. So in order to show you this, I'll just put a ground plane in so we get some shadows. Okay, and I'll move our light. Unlike any directional light, the physical location doesn't matter, it's just the rotation. So if I take a quick render of this now, you'll see here that this is what R's done for us. We've got shadows coming out as you would expect based on the light angle here, and this is rendered at around midday. Now the angle of this light is actually the angle of the sun. So if I were to change the angle of this to somewhere like here, this would put the sunlight about on the horizon, So if I render again, I should get a more sunset image. That's a little bit too much on the horizon, I'm thinking. So now we have a more sunset image, and in fact if I face the camera towards this, you'll actually see, actually I'll probably need to change the angle on that, you'll actually see the sun disk. There it is. Okay, and the shadows are long, and as you would expect at this time of day. So this is quite an easy scene to get to grips with. It's an easy setup. It applies automatically the exposure node. And again, this catches people a bit unawares, because when you start to put textures on, as we now know, you need to gamma correct them. If you've never seen this before and you just whack on the physical sun and sky without understanding what it's doing, you can run into problems. This is why I like in Maya, when something is connected, to check out where and how it's connected, so we get a better understanding of why it's working. Before I delve into any of the settings, however, I must stress, as I said before, that this sun shape is controlled by this node, which is controlled by this node. So if I go up to my sunshade and I go, okay, I want my image a bit brighter, so I'm going to crank the intensity way up to 20. If I take a snapshot, absolutely nothing will happen. Both of these images will be exactly the same. Because as I say, all this is being used for is really the direction of the sun. So if I crank this back down to 1 and hit render, again exactly the same, and it's simply its rotation as well that defines where the sun is. So if I move it over there, you'll see our sun has stayed in exactly the same place. So bear in mind that when you're working with this, if you want to alter the light intensity values or change any of the physical sun and sky settings, you'll have to do it through here and through here. So the first thing I want to do is take you through this physical sky node, and we'll open our render view, close down our hypershade. Whoops. Sorry. So, multiplier. This quite simply is an intensity multiplier. So if we change this to 2, you'll see our scene gets a lot brighter. Okay, there we go. We've kind of blown out, massively overexposed our scene here. So generally I find I'm going to always leave this on 1. Okay, so there we go, back to standard. The RGB unit conversion is pretty much only used when you flip from a simple exposure node to a photographic exposure node. And as we're not using the photographic exposure node, and this is quite a complicated value, I'm going to skip it for the moment. At the end of the tutorial, I will show you how to change this if you're going to use a more complicated photographic exposure node. Haze generally goes from a setting from about 1 to 15. 1 is pretty low haze, and if I actually change the position of our sun to something a little more like so, I'll be able to demonstrate this a bit easier. So if we put a haze value of 5, you'll see our image goes a little more yellow. If we put it up to, crank it up to say 15, you can think sort of sandstorm at this point. So there you go, everything goes very yellow, very hazy. You'll see the horizon line blurs out with haze too. So this is a value you can tweak depending on what sort of effect you're trying to get on your scene. I'm going to leave my haze at the moment at 0. Redshift is pretty much exactly what you'd expect it to be. If we click this to 1, what you're going to see is we get a lot more red in our image. So if we put it to say 0.1, might be a better value. You'll see a slightly more red, sort of at 0.2. We'll keep this. You'll see here this has gone quite a lot more reddish color. So if you want a more intense sunset, or you need a way to shift the red-blue spectrum, this is the way to do it. Saturation is purely an artistic value. It's how saturated the image is. So at 1, it's going to be physically accurate, and this is all about physically accurate lighting. So I actually like to leave these settings pretty much as is. Depending on artistic preference, of course, you're not always after completely real-world conditions. If you're doing an exterior sequence that's supposed to be on an alien world or some such, you may want to change these colors, but I'll put a saturation value of 5, and you're going to see, I think, pretty much what you would expect to see. that the overall saturation level of the image is much higher. Okay, so we're going to leave this on 1. Horizon height changes the height of the horizon. It's a rarely used value. Pretty much you're going to need to use this if you're trying to get atmospheric conditions at the top of the mountain, something like so, and small values here I find I very rarely would go, say, above or below -0.5, but I'm going to show you what it does and then leave you to your own devices on this. So this will shift the horizon down, and you can see not only has it shifted our horizon down, it's quite changed this as well, because it will do that. It won't just shift the horizon, it will affect quite a few things. I'll leave you to experiment with that. So I'll just re-render this so we have a default. Horizon blur is exactly what it says on the tin. It's the amount that the horizon will blur. So if you're after say a very blurry horizon, 0.6, and at a value of 1, the horizon will pretty much disappear. So we have sort of just barely visible horizon. If you were doing an exterior shot again with sort of some mountains really far away in the background and you were looking for this effect, well, that's how it's done. But I'm going to leave my horizon blur at 0. In fact, I think I'll leave it at 0.1 because the 0 is a bit too sharply defined on the horizon for me. Ground color, again, this will have a huge impact if I zoom in and sort of shrink down our ground plate here so we can get a better look at what the ground color is doing. This will have a large impact, so if I just leave it the standard color, quick render, back over to the physical sky settings. So if I do ground color of bright red, because physical sun and sky uses final gather to bounce light around, you'll notice that not only has our ground color changed, all the bounce light has also changed. So we've got red reflections coming in here, a red bounce light, sorry, red here. The building has gone from this grey color to a red color. So bear in mind when you do change this ground color, you're not actually just changing the color of the ground, you'll also be affecting all the bounce light that comes off the ground in your scene. Now, night color, this is the absolute darkest the image will go. So if I grab here our sun and turn it straight up, so basically nighttime, you'll see a pitch black image. Now, if I change the night color to say a lighter grey, what you'll see is this is as dark as the night can go. And this is quite useful if you're doing a sunlit scene where, a starlit, moonlit kind of scene where even at its very darkest it's still not going to be pitch black. So bear in mind, this sun direction is if you're not going to change this with the sun shape here. I like to use the sun shape. I find it very kind of interactive and intuitive, so I'm going to leave my sun shape there. Now, the sky disk intensity. This basically will give you, let me just, so I'm not constantly trying to look for this off screen, and I just want to change this back so it's pointing straight at the camera so we can actually see the sun disk here. So, sun disk intensity, this will be basically the intensity of this. So if I turn this up to 5, you'll see a very blown out sort of big sun disk. I'll just do a screen cap of that. And I'll change it back down to 1 so we can get a comparative look at what's happening. Okay, you can't really see it on this image because it's a bit bright, but our sun disk does actually get a bit larger. Okay, the sun disk scale is what's going to actually determine the size of this. Now 1 is physically accurate, I believe. So if we render with 1, you see this tiny sun, and the problem with this is, although it's accurate, people expect it to be bigger. It's just one of those things. So at 4, I believe this is the scale Autodesk believe that people should perceive the sun to be. So if we scale this to 10, you'll see a huge sun disk here, disk scale. So 4 is the default. So there we go. And if we make this sort of evening, okay, so that pretty much covers physical sky settings. There is one thing you can do. If we look at our camera connections now, whoops, here we go. So we go into our perspective camera shape. You'll see the environment shader is physical sky, the lens shader is exposure simple. But if we create a new camera, you'll see I don't have these environment shaders. So if we render through our new camera, here, render camera 1, you'll see a black image because there's no lights in the scene. There's simply the physical sun and sky. But when it's not connected to the camera, obviously it's not going to show up. So a couple of ways to fix this. You can go in to, and let's just go on to our camera view here. Okay, perfect. So a couple of ways to fix this. Select camera 1, you can open up the hypershade and simply middle mouse drag the physical sky, the physical sky into the environment shader, and then you'll need the exposure into the lens shader, and this will do it for you. So we're now rendering through camera 1 and we have the physical sun and sky and the correct gamma back. Or if you don't want to go through this process, we'll break the connections. If you look under physical sky, you'll see a couple of buttons down the bottom. One says update camera connections, and because we're on camera 1, if we push this, you'll notice that it's automatically thrown these back in. I find it again quite handy to know where they're actually coming from in the hypershade, so if they ever do get disconnected, you can manually hook them up yourself and you know exactly what's going on. Now I just want to finish this off, and I promise you in the next part we're actually going to get down to the shading and lighting of this scene. I just want to give you these basic groundings. This will help you light up any scene, not just the one we're working on. So I'm going to go into now, and we pretty much covered this physical sky. I want to just cover the physical sun, and you'll notice that all of these are basically linked to this. So don't change them here, change them here. You can unlink them if you want to. Really, I don't think it's a good idea unless you're after something very specific. The only thing I ever change in physical sun is basically our shadows. So if I make our ground plate bigger again so we can take a look at our shadows, and I'm going to put this at probably a slightly more extreme angle so we get a longer shadow. And if I do a render here, okay, you'll see we've got this very sharp shadow. Now this is physically accurate. Sunlight always pretty much gives these very sharp shadows, but you know, this being artistic license, you can of course change that. So if I change the shadow softness to say 2, you'll see a blurrier shadow, so it's started to blur there. If I want to make that slightly extreme, I'll change it to 10. Personally, I would never go up that high, but okay, and I have a very blurry shadow now, but it's very grainy, and this is where your samples come in. So if I change this to 64 samples and hit render, you'll see that it's unblurred a little bit, so I probably go to 256 samples. And it's unblurred quite a bit more. But you'll see even on this very simple image, we've gone from a render time of 2 seconds to 3 seconds to 5 seconds, and you're dealing with a very simple image here. But if when you get to deal with a more complicated image, this can add significantly to your render time. So I'm going to leave that at 1 and 8. And if we just take a look from inside our building here, what's happening? And once again, I'm just going to go up to my camera, change my focal length to 28mm. So if I do a render from inside the building, this will give you a better idea of what this setup's going to look like. Okay, I'll do a snapshot of this, and this is the shadow you can see extending outwards from the building. I'm going to bring that shadow inwards, so I'm going to bookmark my camera position, and I'm just going to go and change our sun around here. So now the sun should be shining in the room, so we'll get some shadows within the room. Jump back to my camera bookmark, save this, render again. Okay, and now you can see this is the light coming in through the doorway with a very sharp shadow on it. So as it's taking longer because Final Gather is having to bounce the light around the room, and even with the correct gamma we've got a bit too much darkness here. We're going to address that in the next part when we cover Final Gather, Global Illumination and Portal Lights for interior illumination. Okay, I hope you found this helpful, and as I say, we'll be diving more into shading the room in the next few parts. We just want to make sure that you understand the basics of how physical sun and sky works and how a linear workflow interacts with all this. So at the end of this tutorial you'll be able to light anything up. We don't want to leave you just being able to light up one specific interior from one angle. We want to create a process whereby you can light your own scenes. So I hope this has been helpful, and I'll see you in the next part. Hi, welcome back. In this part we're going to cover the basics of lighting up our room here. Before we start, we'll just take a look at our render view, or I'll just do a quick test render. And we're basically going to go from this to this in fairly short order. So the first thing to do is, before I do anything else, I'm going to open up my outliner, and you'll find this scene, by the way, in the projects folder. It's just called Tutorial Start Part 3. And what I'm going to do is just select all the elements I don't need, and I'm actually going to assign these to display layers. So I'll select the plant pot here, assign it to a display layer, which I'll then name plants. I'm just going to go down and do the same thing. I'll select the stairs, and the same thing with the main room. And just the front door. Last one, I'll just add the main walls in. And now I have a nice, neat, orderly scene. Okay, apparently. There we go. We have a nice, neat, orderly scene that we can now turn the different elements on and off. This will help us with our light setup, just allow us to go a bit quicker. And in fact, I am going to set everything to off except the basic shape of the room. And I'm going to start by just adding in a physical sun and sky. So under indirect lighting, render using mental ray, create the physical sun and sky. I'm going to leave it to default render, and I'm going to take a quick test render so you can see our room interior. And I'm going to go over the process where we can speed these renders up, and if there are any long renders in this video, I will be pausing the video as to not make you wait, but this one should be about a minute, maybe a bit shorter, 40 seconds I would estimate. Okay, 25 seconds, even quicker than I thought. So I'm going to take a snapshot of this because I'm going to show you how to speed this up in a second. First thing I would like to do though is just get the sunlight moving in the right direction. So I'll select the sun direction, and I'll probably have to scale it up a little. There we go. And I'm just going to orientate this so it's actually pointed into the room. Okay, and so we can get back to the same position all the time, I'm just going to select my camera, go to perspective shape, change the focal length to 28. This gives me a longer perspective, of course, and set a camera bookmark by pushing here. So now when I move around, I can always jump back to this camera view. Okay, let's take a render here, and then I'll show you how to speed this up for our test renders. Okay, our render is done. It came in at 21 seconds. I'm going to take a snapshot of this, and here's how we can speed it up. If you go into your Final Gather settings here, if you scroll down a bit, you'll see Final Gathering Map. Now, we need a map file name, so I'm just going to call mine fgmap01, and make sure the rebuild is on, and just take another render. What this will do is we'll save a Final Gather map, so every time we render, we do not need to recalculate these Final Gather points, and this will speed things up considerably. There are of course some downsides which I'll cover in a second. So I'll render again, which will generate this Final Gather map. Okay, our render finished. It took 20 seconds, and we generated this Final Gather map. Now I'm going to flick the rebuild from on to freeze. What this will do is tell Maya not to calculate Final Gather, but instead to use the data we've already stored in this Final Gather map. So if I do a render now, I would be surprised if this takes more than a few seconds. There we go, 3 seconds. And you're probably thinking at this point, that's great, but there are downsides to this. If I were to radically move the camera, so say to over here, and take a render, what you'll see is we have these big nasty areas, and this is obviously not supposed to happen. What's happening is Final Gather doesn't have these data points. It's never seen them before. So at the point where you move your camera more than, well, a little bit, you are really going to need to turn this back on, re-render. And if I do that now, you'll see that my render time is going to go back up again, but I will get the image I'm looking for. So render. And there we go, our render came in at about 20 seconds again, and obviously with the rebuild on, it had to recalculate all these Final Gather points. So something to bear in mind, if you're rendering from one camera angle, this becomes a godsend. It will save you a lot of time, and we'll be using it in this tutorial. But just remember, if you change your camera angle drastically, you are going to need to rebuild your Final Gather map. There is another problem for this, and actually, before I show you what that problem is, I'm just going to put into my scene here a couple of locators, and I find this helps me with focusing the camera in a small room scene like this. So I'll just put one here, and you will see there is some method in my madness. I'll duplicate it and put another one here. What this allows me to do is when I'm moving around a small room like so, instead of having to keep scrolling back in and forward and zooming, and I can click one of my locators selected in my outliner, press F to focus the camera on it, and as soon as I've done that, I'll have an actual focal point for my camera. So if I select this locator, go in, just zoom out a little, you can see now that this just helps me get around this room a little easier. It's just one of the things that I like to do. So I'm just going to leave those where they are. They won't affect your rendering at all. Now, the other problem with Final Gather maps and using them, so I'm going to come here into the doorway. I'm going to create a big sphere. I'll just move that into shot a little bit. Oh, there we go. Okay, and I'm going to give it a hideous red color. So I'm going to assign a new material, and I'm going to be using the Maya Material X pretty much exclusively during this tutorial. So where are we? K is up, of course, and here we go. If you're planning on rendering out passes, shadow passes, reflection, refraction and whatnot, then you'll want to use Maya Material X passes. The thing is, if you have used Maya Material X and you want to upgrade at a later date, if you scroll down to the bottom of the this shaded node tab here, you will see upgrade to passes. So really you can use the Maya Material X or the Maya Material X passes. It really doesn't matter. So I'm going to go up here and give this a hideous red color. Now I'm going to make sure in my render settings that my rebuild is on. So when I actually render this now, and I'll just pause, you can see after we render that we get this color bleed from the red sphere, basically lights bouncing off it and becoming secondary bounce light, primary bounce light in the color that final gather sees. So you'll see this nice red. If we turn freeze on, which will speed up our render, and we render again, I'll snapshot this, you'll see that nothing really changes. The difference is our render time goes from 20 seconds to 4 seconds. So perfect, really. Now, as with moving the camera angle, if you make any large changes to materials, so we'll make this now a very hideous green. Let me just select its material attributes. There we go. So we made this hideous green. I'll render again with the final gather map on freeze, and you'll see that although our sphere has gone green, our bounce light color is still red. Again, this is another limitation with building one of these final gather maps. If I turn that on and render, you'll see now what you would expect to see. Okay, there we go, a nice green bounce light. So these are some of the limitations with speeding up your renders with final gather maps. That being said, with this project we are going to be rendering from the same angle over and over again, and we're probably not going to be changing colors from a hideous red to a hideous green, but it is something you need to be aware of yourself when you start working with this sort of light setup, that if you forget and you leave this on and you change your camera angle, change your major color within the scene, get some sort of unexpected result, remember this. Maybe you have this rebuild set to freeze. Maybe you need to take another render, generate a new map. Anyway, that's some of the pitfalls you can fall into. And the same goes, actually, I'll just cover this last one, because the same of course goes if you radically change the light direction. I won't bother to demonstrate it because I think you have the idea now. But if you radically change the direction of the lighting in your scene, all the bounce light's going to remain where it is. So again, any large radical scene changes, and you're going to have to look at turning your map back on again. Okay, so that being done and those basics covered, we're going to get started with lighting this scene up. First, by going over some of the quality settings, so we can go from this grainy, pixelated render to something a bit more ingenuous for testing with. So I'm going to open up my render settings here. Now, I don't want to raise the quality too high because we'll need to do some test renders, and nobody wants to be sitting here for 25 minutes every time we do a test render. So one of the first things I'm going to do is lower the point density to 0.7. This will speed up your render quite a bit, and I find the point density at 1, it's high. It never really needed, or at least I don't need that much density to take a test render. So the point interpolation I'm going to set at 20, because this will give us a smoother overall effect without actually speeding up our render time. Without actually slowing down our render time too much. Then I'm going to go over to the quality tab, and I'm going to push up the anti-aliasing to 2, and under here I'm going to put this at 0.5. Now this will take a bit longer, but you know, with bad anti-aliasing I find test renders quite difficult. This is my personal preference. Maybe you can get away with a lower number and get the same result. I'm going to change the filter to Mitchell here, sorry, with a 4 and a 4. I'm going to turn the jitter on and take a test render, and we'll see what that's done for us. Okay, so this render has now taken 40 seconds at these qualities, with those quality settings, beg your pardon. The thing is that 40 seconds is not too long for me for a test render, and this quality is good enough for me to work with. And we have here our rebuild set to on. So if we set our rebuild to freeze, because as I said before, we will be taking most of these renders from the same shot angle, even though the idea with the tutorial is to build a lighting scheme where you can take shots from any angle, we're going to concentrate on one and then leave it to you to come up with something slightly different. So anyway, with my freeze on for my final gather map, you'll see now my render probably goes down to under 10 seconds. Okay, 19 seconds. Still not bad. 20 seconds is fast enough. Okay, the other thing you might notice about the scene is it's extremely dark in the back here. In fact, if I just zoom out a little, um, and if I was to re-render again, I'll just re-render a quick swatch down here. You'll see that we're actually very dark, and I did at that time. I forgot to turn the final gather map back on after moving the camera, so it's easy to do. So if you do get something like this, just bear that in mind. Okay, so we're quite dark here. You can see the bottom of the doorway would be very dark. So when we come back in the next part, one of the things I want to cover is actually adding the portal lights to this setup, and I'm going to go over an explanation of what portal lights are. Also in that part we'll start with the window glass and things like this. But I just wanted to take you over some quick final gather settings, show you some of the pitfalls about using the final gather map, and I will see you in the next part where we'll get into some more lighting and hopefully some shading on the window glass. So I'll see you for the next part. Hi, welcome back. In this part we're going to dive right in and start setting up the lighting. Now here's where we left off in the previous part. I have made one small scene change, which I've modelled in the window planes here. These are just poly planes. I didn't think anyone wanted to sit around for 10 minutes watching me model these. So right in with the lighting. Now as you can see from our render view, our scene here is very dark, so we're going to take steps to correct that. And what I'm going to do is set up an area light. We do have 3 windows in this scene. I'm going to set the first one up just so we can take a look at our settings and how it affects our lighting. So go up to Create, Lights, Area Light. I'll just move this in front of the door. Now what you're trying to do with this area light, we'll be using something called portal lights in this tutorial. And they basically act as final gather ray blockers. So when you do a render like this, Final Gather sends out rays from the camera, and these rays bounce around and help us create our lighting. The problem is that with so many holes in our scene, what we'll find is the rays will go out of the holes and just carry on to infinity, trying to take a look at this sky colour and bleed it back in the room. So I'm going to show you how portal lights can stop this. They'll basically act as light blockers. Ray blockers, sorry, for the final gather rays. So rather than the rays coming out of the scene up into the sky and calculating for a seriously long time, not to mention that they won't come back, so we won't get that information back from them. So I'm going to show you what happens when you just put a standard area light in and what happens when you change the area light to a portal light. So the most important thing for us now is to cover up all of these holes, because we don't want any of those rays to be able to escape the scene. Okay, just make sure this is not actually in the building. So there we go. And it looks like I will need to just rotate this here. Actually probably easier just to rotate 180. There we go. Okay, so our light's now coming in the room. I'll nip back to our camera bookmark, take a quick render, and this will lighten up the scene, but there's a couple of key points that I want to go over. So first thing you'll notice is we have a lot brighter scene than we did, but because this is supposed to be physically accurate lighting, you would expect bounce light coming in from the sky to be a pale blue colour, and what we're seeing here is none of that colour information coming through. This is because our final gather rays have just exited the room, gone up into the sky and not come back, so we're not going to get any of this outside bounce light, which means if I was to change this scene to say a more evening sort of sunset colour, you would expect to get some sort of lovely reds and oranges coming into the scene, but as I'll show you now, you're just not going to get it. Okay, so as you can see, our lighting here is still extremely bright, so our area light isn't actually obeying the settings outside, and we need some way of connecting these all together. So I'm going to do this with a portal light. So I'm going to go back here and change here our sun direction back to a more daytime. I'm going to select my light under the attribute editor, under the light shape. I'm going to scroll down until I see custom shaders. In this custom shader I'm going to put a light shader, so a portal light, and you can find that just under lights here, mental ray lights, portal light. Okay, now a couple of things to bear in mind before we change any of these settings is, again, I'll take a test render from our camera bookmark, and I'm taking these test renders so hopefully you guys won't need to. Okay, as you can see, we get a huge difference as soon as we tell that to become a portal light. Now, one thing I wanted to cover is, as with the sun direction light, changing this value on this area light. So if we scroll up now and look at the area light's intensity value, if I was to change this to say 1000, you might expect us to get a hugely bright, overblown out scene. But as I can show you, this is not going to happen, because changing this value now has no effect on the light whatsoever. All the settings for the light are now connected in that portal light shader. So I don't think I need to continue with this. You can see that we're going to get exactly the same result we had before. So if you want to change the intensity of your light, you now need to scroll down again to custom shaders, click here and change the intensity multiplier here. So if I do this, you'll now see that our scene gets brighter. And I won't do the full render, I'll just go like so, and you'll see that our scene has stayed the same. This is because we missed one important element of this portal light, which is if we select the area light again, actually I'll just do that in the outliner. Okay, you'll notice under the mental ray options, which are here, use light shape is not ticked. Now, in order for a portal light to work correctly, you need this use light shape. You also need it to be visible. So if I scroll down now and click here, make sure the intensity is on 1, and do another render, you'll now see this portal light has actually become active, and you'll start to see some color bleed here into the room. So now we have our portal light actually active. You can see here that we're getting this nice blue color bleed into the room. So if we change the sunlight to sunset or sunrise, you'll see a nice yellow. You'll see whatever you see in the sky actually bled into the room. And now if we change the intensity multiplier to say 5, we will actually see that that affects the scene now. Okay, with the intensity multiplier set at 5, you can now see the effect of this colour bleed much more clearly. We've got this blue light from the sky here falling all the way through the room. So I'm going to set this down to 1, because this is not actually the way we're going to lighten up the scene. At 1, this is much more physically accurate, and that's sort of what we're looking for. Although you don't have to be too religious on it, this still is an exercise in creating a room for the lighting conditions that you want. It's just at the moment we're not going to use this method to get extra light in the scene for a variety of reasons we'll cover later on. So first thing, we need to get this extra light in. And just to, before we go any further, just to recap, in order for your area light to become a portal light, not only do you have to connect here the portal light shader, you also have to click use light shape and make it visible under the area light settings under the mental ray drop down. So now, to get brighter light, there's a few ways to do it. One of the most common is to turn up the number of secondary diffuse bounces within final gather, because at the moment final gather is bouncing the light once from this light. It bounces it once because when you use a portal light you get one free light bounce with it as well, which is nice. But if we wanted to bounce more light around the room, we can turn up the secondary diffuse bounces here, and I'll take a quick render and show you what that does for us. Okay, so here is our scene with 3 light bounces, and here is our scene with just the 1 from this portal light. So you can see it's lightened it up a bit. It's also increased quite a lot of the render time. Now, I prefer to leave this at 0 and let global illumination calculate the secondary light bounces. I find it faster and it gives me a nicer light. Now you can use Simply Final Gather on its own if you want to, but as I say, for this tutorial we're going to be using GI too. So when I use GI, I need to emit photons into the scene so global illumination can calculate these secondary light bounces. So if I take a look in our area light here, you will see under caustics and global illumination, emit photons. Now if you want to tweak these settings, you can. I find it default, but just fine for this particular room. So I'm going to go up now and take a render, and I'm going to show you what this does for us. So take a quick snapshot. Now as you can see, our rendering time went up a little bit, but not as much as happened as you might think here. In fact, if you look at the difference between the two images, there's not a lot really in it, and this is because, and this is the thing I think a lot of people forget, is that when we're using this portal light, simply emitting photons is not actually enough to get the effect we're after. We have to go down to our light shader and give it a photon emitter as well. Now you can create a new portal light shader if you want to change the values between the GI and the final gather, but I'm just going to copy and paste the same light shader because I find that in sync they're fine. So here we go. Now I have the portal light shader for GI as well, and if I do this again, I think you'll see quite a change. Okay, welcome back. Here's our finished render with global illumination also on the portal light, with its portal light settings, should I say, on the area light. Now the change is not drastic, it is quite subtle, but you can see we're having light bounced around up here, and our problem with the scene at the moment is that we still have these two holes here. So we're going to go ahead and set up the area lights for these two. We're going to make sure that they're both portal light shaders for GI and final gather. So I'm going to go to lights, area light, and I'll just move that out here and make sure we cover up this window. Just flick that round, actually flick it round to 90 exactly. Move this in. Now you don't have to be too precise with this, as I said, you can get it, just make sure that it covers the window so we don't get any of those rays or photons escaping the scene. That seems to be a little bit embedded in the wall there. There we go. And I'll just create another one for the back wall. Okay, push that in a bit. Okay, now let's set these up to be portal lights. So we'll go into their attributes, remembering before we do this to make sure we have emit photons turned on, use light shape and visible. Now I'm going to actually use a different portal light shader for this because I want independent controls of all the lights coming in through the window. So we go down to mental ray lights, portal light. Okay, I'm going to leave it on its default. Jump back to the area light, and once again, for me, these two connected is just fine. I'm never going to want to raise the exponent of the photon shader and not raise the intensity of the light shader. So we'll just do this last one, and again, another portal light, and once again, we'll be tweaking these portal lights to a degree when we come to our final render, and once again making sure that we've remembered to emit photons and also use light shape and visible. This is important, as I said before. If you don't do this, then it will not work as you expected it to. So I'll jump back to our camera bookmark. Now with these two lights active, you'll see a much greater degree of overall incoming light as you'd expect. Okay, now with all three of our lights in place, you see a much better degree of overall illumination. A lot of this speckling disappears, our corners come into more illumination. Obviously you're still getting the shadows from this way because this is where the sun is pointing, so What we've now done is given ourselves this greater sense of a well-lit room. And one thing I would say, the reason why it's still fairly dark is because when you're using this physically accurate type of lighting, you're actually bouncing rays around the room and it's reporting back on the colour it sees. Now at the moment, if we look at our material attribute, the colour it sees is this grey, so it's bouncing grey light around the room, which is why you have this kind of overall darkening effect. Now if we just start by assigning a new material, and once again I'm going to be using pretty much exclusively the Maya Material X. Now I'm going to pick for it a nice sort of, well, not that colour of course, a nice sort of beigey off yellow colour for the room here, so a nice bright colour. I'm going to leave the weight where it is. I'm going to turn the roughness up. This will give us a sort of a more powdery like coating of a matte paint. Now we don't want it to be reflective, so I'm going to turn the reflectivity off. And under bump, don't need it, under ambient occlusion I'm going to flick this off. This material actually has built-in ambient occlusion, so we can use that. You can do it this way, or if you want to you can do an ambient occlusion pass at the end of your render, or you can skip the ambient occlusion altogether. So I'm going to, where this use detail distance is on, I'm going to send it on with color bleed. What that does for us is, normally ambient occlusion only darkens an image. With color bleed on, it'll actually bleed in the lighter colors as well, and it'll give us some more accuracy. Now the distance, I'm not going to need such a big distance, so I'm going to turn it down to 5. And the samples I'm going to leave at 16 while we're rendering. If you get sort of a dirty, grainy image, you can turn this up. Shouldn't need to go much higher than 64 though. So with this done, and I'll actually apply the same material to this, and I'll actually just name this material so we know what we're working with. Okay, and I'll need to apply it to this as well. Okay, and finally to this. Okay, so if I go back to our camera bookmark now, our overall lighting will increase quite dramatically. So I'll just bookmark this and hit go. Okay, so you can see here, by giving Final Gather and GI the chance to bounce around a much lighter overall room colour, we've gone from this to this. So this is the basics of lighting with physical sun and sky, is to create portal lights to block the Final Gather rays from leaving the room, and also to take into account that light does now actually bounce around. So if you have a room with, say, very dark wallpaper, you might need to tweak your lighting based upon this fact. What we've also done is connected the outside with this blue colour bleed here and here from the windows to the inside. So without portal lights that really doesn't happen. So if I go now and change this to a quick sort of sunset, you'll see now by just controlling this physical sun and sky, I will actually get a completely different result, both inside but both outside, but more importantly for us, inside too. Okay, you can now see here that by using those portal lights and connecting the inside and outside, when we go to a more sunset scenario, we get a lot more of this sort of golden yellow colour coming into the room. So you can see the advantages to this, and our shadows of course get much more elongated as they do in the evening, and you can see the advantages to this type of lighting scenario. With one small change to our overall light here, we dramatically change the look and feel of our render. So without having to go to every light we have in the scene and say, okay, now be more yellow and now be a little dimmer because we're going into evening, we've got this very powerful level, very powerful degree, should I say, of control over the illumination with just physical sun and sky. Now I was going to do the windows in this part, but I think I'll leave them to the next one. If you want to experiment on your own, please play about with sun direction, and you will see that we have this lovely connection between in and outside. You might want to change the values of these back windows. For instance, if we were to go in here and flick over the intensity multiplier on the back windows to a much lower level, so I'll just put both of these back windows to 0.1, and again remember that the controls are now under the portal light, not under the light intensity. So I'll just flick this on. I'll do one last quick render, and as I said, I'm doing these renders so hopefully you don't have to, save you some time. Okay, and as you can see, by tweaking the back windows here, by turning the intensity multiplier down to 0.1, we've got a darker sort of overall illumination in the back of the picture than we do in the front, giving us a bit more of a dramatic effect. The splotches you see on the walls we will of course be getting rid of. This however does require a slightly longer rendering time, so for our test renders I'm going to leave it here. Please give your portal lights a tweak, play around with them, see what they do. Sun direction, as I say, will just control the time of day basically. So see you in the next part when we'll get the windows. We'll go for this lovely sort of self-illuminating look with subsurface scattering, and we'll do these sort of frosted glass patterned windows as well. So I'll see you in that next part, and hope you enjoyed it. Thanks for watching. Hi, welcome back. In this part we're going to take a look at lighting with subsurface scattering for the windows, and I'm just going to jump right in and let you guys just follow along. So the first thing we need to do is go to our channel box here, bring our windows back. Helps to have something to work with, and I'm going to start with this center one because this will really be the main focal point of the image, or at least of the image the way I was shooting it for the camera angle. So I'm going to go to its material attributes, and we are stuck here in the initial shader, Lambert 1, so we'll assign a new material. And again, as I said, pretty much exclusively using this mere material X. I'm going to just rename this to Door 01 Window Center. Okay, now although these will ultimately be subsurface scattering materials, we need to create a base material to feed in to the subsurface scattering, so all will become clear. So I'm going to start by adding a file texture here, and I'll go under my windows, and it is glass middle, I believe. That's the one. So back to our material, and under refraction I'm going to feed in the same file. In fact, rather than just creating these file nodes all over the place, I will actually go into the hypershade, under textures, grab our file 1 here and stick it in there. This just stops us having tons of textures in Maya. This keeps our workflow a bit neater. I'm going to keep the reflection the same as it is, oops, except I'm going to go down here, ticks like so, and if I do a quick render now, let's go back to our initial camera position. I think you're not going to see quite what you expect to see. Aha, and I also forgot, we need to be fully transparent as we are going to be window glass. Okay, you see it's very dark, it's not at all what you're expecting. This is because we take a look under our quality settings. If you scroll down to ray tracing, you've got one reflection and one refraction limit with a max trace depth of 2. This is too low for us, so I'm going to set it to 5, 5 and 10. This will give a better result, but it will also slow down rendering. So bear in mind, here we're coming through one pane of glass, 2, 3, 4 maybe. So I really would like to leave this at 5, 5, and generally this is the sum of these two. So you could go in there and set this to 50, 50 and 100 if you like, but it will slow down your rendering a lot. So try and keep it to the minimum that you need. So now we'll re-render, and I think you'll see something that looks a little more transparent and glass-like. There we go, you can see here this is actually transparent gradient and it's picking up the background color, but it looks a little flat and it doesn't look very luminous. So I'm going to start making this luminous by adding a subsurface scattering material to it. Now you might think that we've created this unnecessarily as we're going to change the material, but as I said, this is basically going to be a plug-in for our subsurface scattering material. And I'm just going to change the index of diffraction to 1 so it's not completely refracting the background here. Okay, so now we'll get on with adding this subsurface scattering material. So in order to do this, I'm going to assign a new material here, and I'm just going to do a quick search for SSS, and I'm going to use the Mist Fast Shader 2. Now this is only available in Maya 2013, I believe, so there'll be an addendum at the end of this tutorial to show you how to do it with the normal subsurface scattering material. I decided to use the new one as it's new, and there's plenty of information on the internet about the old one. I'm going to take you through both, but as I say, I'll do the old one at the end of the tutorial as to not interrupt the workflow here. So I'm going to assign that shader, and the first thing you'll notice, if we just take another test render, I'm going to keep this. It's that it doesn't seem to be, letting in a lot of light. It seems to be more of a solid color. This is because we need to set up the light map. So if we click the checkbox, it will do it automatically. Now we need to change a few settings in here. We need to make it writable, and generally the writable file size and width will be double what you're using for your final scene size. So I believe I'm just using standard 720 HD. Let me just have a look here. I am indeed. So we need to double this, which would be, math teacher is now screaming at me, which would be 2560, and this, which would be 1440. Yeah, 1440. Basic math goes out the window there. And if I render again, you'll see not a lot's happened. It's because we need to make some other connections to actually get this shader to work. So in our hypershade, I'll just find it and graph the network, and I'll also, while I remember, rename it so we know what we're working with. And I'm just going to name this top center subsurface scattering. Okay, so extra connections. So we've got the light map texture in. What we need to do is put an actual light map in the shading group here. So I'm going to expand this out so I can see the shading group. I'm then going to create another fast LMAP Mist shader here. So just put that down there, click here, middle mouse drag this into the light map shader. So if I zoom out a bit, we can start to see some connections here. But we're still not done, because under the fast LMAP we need to, let me just flick this down, go to light map right and drag in the mental ray texture. Hang on, there we go. So now you've connected in this sort of diamond shape. That should be your subsurface scattering material connected, and we'll take another render. Okay, and we still look quite dull, so let me just double check all the settings here. This is linked up, it's writable. And I've forgotten something critical. The file size depth needs to be 32 bits. Okay, so everything is now correct with this fast surface shader, but if I do another test render, you'll see that we're still getting this very dull, dark sort of image. Doesn't look like there's light pouring through it. And this is because in order to work a subsurface scattering material on a piece of geometry, needs to have some depth, and what we have here is a flat plane. There's no front and back to it. So if I just go up to Edit Mesh under the Poly menu and extrude it a bit, I'll click here for its modifier, and just, you don't need to do it a lot, just a bit will do, and I'll just move that out to see how thick we got that. Actually I'm still under extrude here, so object mode, and we'll see how thick this is. That's probably a little too thick for us, so I'll just, and you just need to give it some depth, otherwise you're going to see the effect that we just saw. So I'll just jump back to the camera view, and without any depth a subsurface scattering material won't really do anything. So if I click go now, you can see here that we get a very different result. We get sort of a coloured sort of filter of light coming through, and I can go to the material attributes and now start to plug other things into this that will make it look like a stained glass window. So if you want to check your subsurface scattering material is working, if you push up either the back or the front weight, in this case we'll push up both just for a graphic demonstration, and you can see that got a lot lighter. So our subsurface scattering material is working. Now we just need to make it look like a stained glass window. So to do this, we're going to go back to the hypershade, and this first window texture that we made, that was just a flat piece of glass, we're actually going to plug this into our subsurface scattering material. I'm just going to delete that horrible green material we made at the start of the tutorial. So if I click on the subsurface scattering material we're using, and I'm going to middle mouse drag this connection into the diffuse illumination. Now I'm going to show you what that's done, and I'm going to show you what this does along every step of the way, so you can see how this has changed from this sort of skin subsurface scattering material into an actual stained glass window. So if I hit render, okay, as you can see we start to get a bit more stained glass window like. I'm also going to drag this in to the specular illumination and hit render again, and now we have a much more stained glass window effect. So there's a few other connections that I want to hook up. I just want to grab this, and this is a bit of a cheat, it must be said, but it does work for stained glass, or at least I like the effect it gives. So I'm going to middle mouse drag the original material, the Maya Material X we created for the window, into the front SSS color. I'm going to pick its diffuse, front SSS color, back SSS color. Okay, I'm going to close this down, and I will do another render for you guys so you can see what effect that's had. So here we go, and you'll see the effect is quite subtle, but here I have that sort of bleed into my dark edges, which I don't want. So now we change the whole thing a little bit. Okay, we still have some other things to do with this material. For instance, I don't think it's quite bright enough. We're not really getting a lot of illumination through it. So you can start to see here a small color bleed coming through from these yellows, and down here especially you get small color bleed coming through. You'll notice this more when we put the actual window frames back. But if you want to increase the amount of light coming in from behind this window, you can select your subsurface scattering material here, increase the back weight, so the amount of light coming in from behind, up to 2, and just to show you what that does, I will render. Okay, I did a full render this time. You'll see here a window's gone a little brighter. The problem is that we're now blocking a lot of this light, and I'll show you another problem that we have. If I was to change this light to a more midday, so I'll go sort of straight down. One of the nice things about this is getting a nice gentle orangey illumination from the background. If I change this now to midday, which will be a blue, this light will actually update as well, the light coming through the window, which is what I want to achieve in this tutorial, is to be able to change my main sunlight direction and change the whole lighting for the scene without going in and tweaking a whole bunch of settings. So I'm going to save this, and I'll show you the light change on this, but also a problem we're going to have with the shadow on the floor. Okay, and here we go. So you'll see that our material color on this and the light pattern and quality coming through it have quite radically altered. The problem is that I would expect to see a shadow on the floor here. I would expect to see a nice light pattern from this stained glass, and I'm just not seeing it. Now, a way to fix this is if we select our material attributes here, drop into the shading group, open up the hypershade, grab the original center door material, so the original Maya Material X, and just pop it in the subsurface scattering materials shadow shader. So now I think you'll see that when I just render this little test area here, we get this really nice sort of shadowed pattern on the floor. There we go. So now we have the light coming through this, and if I re-render this portion also, you should be able to see here, if I take this away, that where we rendered, it's actually now letting more light in as well. So that's basically the simple setup of our subsurface scatter material. We're going to do a few more tweaks, but we'll come to that after we've just popped in these other two window panes here. So first things first, I'm going to assign shaders to these, so assign new material, and once again we're back to creating the Maya material X in order to plug it into the subsurface scattering. So I'm going to scroll down here to Maya material X. I'm going to come up to the color again and just assign the correct window texture. So this would be stained glass top side, I believe. Yes, it is. Okay, so jump back to the material under refraction, same drill as before, and again I'm going to reuse this texture. So under textures, file 2. Okay, make sure we're using a transparent material. Click here. Okay, we'll do a comparative test render, so you can see the difference between the stained glass and the actual glass. I don't need to re-render that whole stained glass panel. So as you can see, without the subsurface scatter material, this is kind of dull and flat and really doesn't look like stained glass. You would expect when the light hits stained glass for it to kind of have this nice subsurface scattering glow effect, and this just does not, which is why I decided to go with the subsurface scatter material for this. Also because it's new in Maya 2013, I thought I'd walk you through some of the process of setting it up. So before we get too far along, the same as we did last time, because the subsurface scattering material is going to need some sort of thickness or width to shine through. Edit mesh, extrude, go here, just extrude it a little bit, that will be enough. Okay, back to object mode, and that will do now for us to set up our subsurface scattering. So assign any material, and I'll just, so again, fast shader 2x. Okay, and once again set light map up, writable, and double our scene size, so 2560 1440. Make sure 32 bits this time. Okay, and now we'll need to the hypershade to get the other connections in. So materials, and here I have the old shader, so I'm just going to copy the name from that and give this one, I'll call it LR for left and right. Okay, so we'll just check this is fine. So we'll go into here, yep, this is fine, we're on 32 bits, so let's just graph it now. Add in the light map, okay, which, if you'll remember, needs to be connected to the shading group. So under shading group, and my light map has now disappeared, so just grab this one, light map shader, and while we're here, we'll feed, oh, no we won't. While we're here, we'll feed in our new material into the shadow shader, and before I do that I'm just going to rename it. So I'll call this pretty much the same as I called this. I always quite obsessive about naming, because when you're working with a hypershade, it is very important, because we'll have a few materials at the end of this tutorial, and I've purposefully kept it material light because I didn't want this to become a tutorial about, you know, how to shade in a wooden floor. I wanted it to be more about the subsurface scattering, the lighting, global illumination and whatnot. But I always like to name these files quite obsessively. It just helps you a lot further on down the trail. So here we go, and I'm going to drag in the door, window, left, right, which was the Maya material X as the shadow shader, so we end up with a nice patterned shadow on the floor here. Okay, so under the light map shader, we need to go into light map right and connect this in. So if I did that actually connect in, let's have a look. Yes, it did. Okay, So that should be it then. Graph this network. Okay, that should be in. I believe we have the map here and then here. Yep, we have the whole thing. Okay, so let's take a test render of our area here now to make sure we do have all those connections hooked in. It's not so difficult to miss one. Okay, perfect. You can see here that our subsurface scattering material is working. So now it's time to jump into adding the stained glass to it. Okay, so same drill again. Open your hypershade, grab your door left and right material and add it to the diffuse illumination, specular illumination. Throw it into back SSS color, so the diffuse to front SSS and back SSS. No, that's radius, we want color. Okay, now I'll do another quick render and we should see our stained glass window in here. Which we do, and if I go here for the shadow on the floor, we'll see that we get the proper shadow on the floor. Now I'm just going to delete this window pane and duplicate this one over so we don't have to go through all that again. So Control D, of course, and I'll just focus in on this and we'll throw it about there. We'll adjust it in a little minute when we put the window frames back in. Now these bottom windows are also going to be subsurface shaders, so this is the last time we'll have to do this, so I'll just walk you through the process once more. So assign new material, and it will be a Maya Material X for the window, or for the window plugin for the subsurface scattering, should I say. So once again I'm going to go with color up here, and I'm going to pick File and stained glass door side, I believe. Yep, so that's perfect. Drop back to the material, under transparency I want to make that completely transparent, and once again I'm not going to duplicate all those file nodes, so up to the hypershade, textures, file 3, drop this in the transparency. So this will allow us to set up this subsurface scattering material, and just tick here. So that's the basics done. Again, another quick blast test render to show you the flat window. And there we go. This is the flat window image. And I noticed something quite wrong here actually. Let's just check this. There we go. Sort of mistake there. Instead of dragging the file into the color, I actually dragged it into the transparency, which is not at all what we wanted. So let's try this again. And there we go, that's what we wanted. And we want to make this a subsurface scattering material now. So again, this is, promise you the last time we'll have to do this. Assign new material and just narrow it down a bit. Again, the same, shader 2 X. Okay, and now before we do anything, I'm going to go and rename my window material here. So which would be here, there we go. And I'm going to name this window bottom, left, right. Okay, now hypershade, sorry. Okay, there's our new subsurface scattering shader. So I'm going to grab one of the old ones, just so I can get the same naming convention. And I'm going to call this window bottom, left, right again. Okay, so again we need a new light map. So this is just created mental ray textures 3. Again, writable and double the scene size, so 2560 by 1440, making sure to check 32 bits. Without it, will not work. Okay, that's all correct. Just graph this network out here. Okay, under the shading group, which is where we want to be. No, this is the wrong. This is door, left, right. This is door, and this is bottom. Okay, there we go. Okay, so push this out. Now we need to put this light map shader in. So once again, light map, and then we need to connect this up to texture. So we are done here. Scroll out, you'll see we have all the connections made together. So at this point, I think we forgot one important thing, which was to give this some depth for the subsurface scattering material. So edit mesh, extrude, and you'll want to check that if you noticed weird effects or your subsurface scattering is not working, you might want to just check that you've remembered to give it some depth. It's easy to forget. So drop back to object mode. Whoops. Thank you. There we go. And quick test render to make sure our material is working. Okay, our subsurface scattering material is working. I can just see the sort of horizon line through it there. So now once again it just remains to connect up the door material that we made, which is here. So again, diffuse illumination, specular illumination, front SSS color, diffuse, front, back, done. And that should be our connections pretty much made. And there we go. Let me just make sure I added the shadow shader in. I did not, so again you just have to, in the subsurface scattering materials shading group, let's bring up the hypershade here, and this is our door left, right, bottom, yes. So graph the network, bring up its shading group, and what we need to do is grab this and bung it in the shadow shader. And now when we render, you should hopefully see the shadow on the floor here. Yep, there we go. Okay, I just want to copy this one over to here. Control D obviously, and I'll just throw it in there for now. We'll get it lined up more when we get the window panes in, and you should see this one has also changed. Okay, and we should have thrown this one in over here by now. Okay, so there's the basics of our stained glass with subsurface scattering. Now, if I just turn on here the window frames, excuse me. Oh. Okay, now I'm going to take another render, and again, I'm just taking these renders to hopefully save you some time. So I'll clock this whole thing and hit render. And here we have the basics of our stained glass, and if I actually zoom in here, you'll start to see some colour bleed coming through off the different colours of the windows. So here is a light yellow colour bleed, here is the orange from this, here is the orange from this orangey colour, and we'll make this a more pronounced effect. We'll also tweak these a bit to get them looking a little better, and as I say, these will respond to the outside colour. So if I make this sort of longer in the day, and hit render. Okay, so this is later in the day, and you'll notice that our subsurface scattering material has changed colour. The light plumes coming off it have changed. So basically, again, with this idea of connecting the outside and the inside so the light conditions always look realistic, holds true. We have our lovely shadow shapes here, coloured shadows on the floor, and we'll come back in the next part and take you through these two windows and a bit more of the basic shading. We'll also look at tweaking these subsurface scattering materials. So I hope you find that part useful, and I will see you in the next part. Thanks for watching. Hi, welcome back. In this part we're going to jump straight back in with finishing up our stained glass here, and one of the first things I notice is that the colour is very washed out. This underneath here should actually be yellow, and this goes back again to using that physical sun and sky with a gamma corrected lens shader, so our exposure shader. What we've done here is we've plugged the texture in without readjusting its gamma. So I'm going to do that now. I'm just going to look under material attributes. Actually, I'll do this in the hypershade, much easier, and I'm going to select my door left and right for the bottom panel. I'm going to graph its network, and if you don't see all these individual connections, you need to go up to options and untick merge connections. Okay, so now we've done that, I'm going to pull this out of the way, and what we're looking for is this refraction color. So we're going to select the refraction color and get rid of it. We are then going to drop in a gamma correct node, which I've just searched for up here, and we're going to plug this texture into this gamma correct, and we're going to plug this gamma correct back into the refraction color. Okay, now we need to change its value to reverse the gamma, 0.454, 0.454 and 0.454. Okay, and when I render again now, I think you'll see an overall much stronger image here. Oh, I do apologise, Maya's decided to play silly buggers on me. I will just re-render the whole scene. I'll be back in a second. Okay, welcome back. Now on this particular window we're not seeing a great deal of difference. The colours are a bit stronger. The reason for this is most of this window is actually transparent, so when I do this again on one of these top windows, I think you'll notice a much more dramatic change. So let's select the centre window, graph the network, grab hold of that refraction colour, which should be this one. So we'll get rid of the refraction colour, drop in another gamma correction node, stick the file and its value, change the gamma to 0.454 for all three, red, green and blue, and then simply drag this up to the refraction color again. Okay, and now when we re-render this, you'll see quite a change in the colors and intensity on the center window. So you can see here we have quite a big difference between what we had before and what we have now. Let's find where we were before, sorry, and now. So all of these lovely yellows and oranges have come back. I just need to do this one, so the same procedure again, into the hypershade, find our window left and right, graph the network, remove the refractive color, add another gamma correct node, simply drag this into here, and again 454, 454 and 454. Okay, reconnect this back to the refraction color, and when I render again you'll see a change now with these new ones too. Just save that image, hit render. So as you can see, once again we get this much brighter, bolder colour. Now before I go any further with this, I want to put a backing plate on here. This is something I normally do in post-production, but as a reference for us I'm going to throw one in, and it's actually the one I used on the final tutorial image. So I'm going to throw that in now, but before I do, you'll notice also that when we intensify these colours, we get a nicer light plume, so a darker orange up here for this colour and a yellow down here for this one. So it is well worth dropping that gamma correct node in. Okay, so I'm going to swing outside my house here, just drop in a standard polyplane to put our background image on. I'm going to rotate this up and then size it to a decent size. Okay, I'm not going to be too precise with this. I just want to get it large enough to cover all those windows, and that should do it. Let's jump back to our camera view. Okay, that seems to be covering all our windows, and I'm going to assign a new material to it. And for this one, I'll just use a standard Lambert shader. And file. And I'm just going to drop in a photograph I took the other day. So there we go, and you can start to see that come in through the background now. So actually looks about right where it is. So I'll just take another test render of these windows with that backing plate behind. Okay, and you'll notice here that I've actually forgotten to go into the polyplane, and under render stats I need to turn off cast shadows, receive shadows, primary visibility, and I'm going to leave the rest where they are. So remember, if you don't turn these off, this plane that you're supposed to just be using for a background plane is actually going to block all the light trying to get into your scene. Actually, I'm going to turn primary visibility back on because we still want it to be visible, obviously. So let me just snap that. Okay, as you can see with the backing plate on, our image starts to look a little different, and I'm going to just adjust the position of this because I'm not so happy with it. So I want more bright sky up in the sun, and I'm also going to go back to our subsurface scattering materials and just change this back weight. I'm going to crank it up a notch because I want these windows to really become a focal point. So you'll see what happens when I do this. It'll push more light through the back of the subsurface scattering material. Okay, so you can see here that our subsurface scattering material has got quite a bit brighter compared to its compatriot here. So I will just go down material attributes and crank up this back subsurface scattering weight to 2 as well. So if I just quickly test render this, you'll also see this one go up. Okay, and as you can see, compared to its brethren here on the right, it's a lot lighter in colour. This is an effect I want. It's also pushing more of this subsurface scattering light now into the scene, which also I find quite desirable. What I'm going to do now is just put in these 2 windows. But before I do that, I'm actually going to just get rid of these top windows because our final shot angle is going to be from somewhere down here, so we're not going to see them. I'll leave it as an exercise for you guys to put them in if you want to change your shot angle. But for now, I just assign any material to these, and we're going once again with the Maya Material X. Okay, and I'm just going to give it a refraction, which I will make a texture. So go into the Windows folder, and I believe this one was bottom side. Yes, although I don't want this one to be stained glass, so I'm going to go with bottom side clear. I'll delete this and copy this material over. Control D, obviously. And now I'll just make sure that's been set correctly. So we should just have a bog standard basic transparent construct. Let me make sure that I actually put the transparency on this. I did not. There we go. Always helpful when you're trying to make something transparent to make sure you've actually made it transparent. Okay, I've got my camera in a different position, but I can see that's the basic transparent material. So I will dive back to camera view 1 and probably get this a bit more accurate when we put the window frames back in. So if you remember the reference, what we actually want here is not quite transparent. We want a sort of nice frosted patterned glass sort of look, and this is actually quite easy to achieve. We turn the transparency down to 0.8, and I'm just going to throw in here a standard bump map, so under here, and I'm going to use a fractal pattern. Now this will create a very different result depending on what sort of pattern of bump map you use, but I find the fractal works quite nicely. I'm going to turn this down to 0.1 because I know from experience that 1 is probably way too high. And if we go back to our render now and click again, you'll see that we have this sort of patterned wavy glass. Okay, so as you can see here, we've got this sort of very subtle at the moment wavy glass pattern. If I want to make that a bit harsher, I'll just go in and turn the bump map on, but for now I'm going to consider that good enough. We'll go back in the final render tweaks and, you know, make all of this a little better overall. So I'm going to turn the rest of the room on. So I'm going to go to our channel boxes here, and I'm just going to turn the main room on. And what I'm going to do now, one of the first things I like to put in is the floor, because it's a very large contribution to our scene, and as soon as those vinyl gather rays start hitting it and bouncing the floor color into the room, then we'll might need to look at tweaking our overall lighting. So in this case, because I haven't cut a separate object for the floor, I'm just going to select the face, assign new material to the face, and once again mere material X. I am then going to go up here, set a color, texture, and as they say, here's one I made earlier. So here's the floor, and as you can see when I bring this in, we get this nice bordered pattern that was simply from this texture. I literally just UV mapped the floor plane, went into Photoshop and just added this all in manually to get me this nice surround border on the room. So I'll drop back to object mode. Now we're going to need to go up to the material attributes, which we'll now have to find in the hypershade. So it would be a very good idea to name this floor. So select the material here, and we don't want the floor to be this reflective, so I'm going to turn the floor down to a reflection of 0.2 and a glossiness which will help blur our shadows and blur any light that hits the floor to say 0.8. Now it's not going to be at all transparent, so this should actually do it. I'm going to go ahead and pop in the bump map as well. So I'm going to use the standard bump. Like I say, I like to keep the overall bump for mental ray specific bump maps like the rounded corners and whatnot. And I'm going to open up another file node here, and I know from experience that this bump value again is going to be way too harsh, so click here to link it to a file and load in your floor bump. Now I can already tell from the picture that this hasn't been gamma corrected, so before we do anything else we're going to have to do that. Drop in a gamma node, and let's just come down here a bit. Okay, let's make sure we're all connected properly. We are. So I'm going to want to take the texture, wherever we put it. Hang on, let me just clean up the hypershade here. I've got too many things on the floor, and regraph this network. Okay. So here's my file texture for the floor, and I need to put obviously a gamma correction in the middle of this, so gamma correction. I'm just going to delete the floor diffuse, drag this back up to which will put the floor diffuse out color back to the gamma, and then I'm going to drag the gamma back up to the diffuse color here, which will just intersperse this in between. And as we know by now, probably by heart, 0.454, and sorry, Maya's just slowed down on me a little bit. It's because I'm recording. 0.454, and you can see here that we get that rich warm texture instead of that washed out one. Okay, so I'm going to take an overall render so you guys can see how the flooring changes the illumination in this. I'll be back in a second. Okay, and here's what we look like with the floor in. So as you can see, with this particular lighting setup, the reason why we're using it is that it becomes really quite fast to get all the rest of the shading in from the scene, and in fact we should just about finish off in this part. So now I'm going to introduce the staircase, and also we need to gamma correct this background image because it's looking a little washed out. But you'll notice now that the contribution here from our frosted glass all of a sudden looks a lot better. We just have to shade this trim around the door, and like I said, you can really go to town on a scene like this. I've kept it as simple as possible, so we're not, you know, going through 4 hours of different materials and shading within this particular tutorial. And as Maya has slowed down on me, I'm going to reintroduce the rest of the shading in the next part. See you then. Hi, welcome back. Sorry about the rather abrupt end to the previous part, but here's where we left off. Maya had decided to slow down drastically on me. It happens sometimes when I'm recording. So we'll come back now with the introduction of the stairs, finish up the majority of the rest of the shading, and then we'll come back for one final part just to tweak the overall look and get a better sort of light consistency and a better quality to it. So I'm going to reintroduce the stairs. There we go. So this should be shaded in no time at all. Basically, I'm going to flip open the stairs group under the outliner, the cupboard, banister will need shading. So the banister I'm just going to assign new material to, and again I'll use a new material X. Let's just get its material attributes up, and I have a wooden texture here. There we go. You can use your own. We're going to need to gamma correct that texture. We'll get to that in a second. I'm going to now select this, and I'm going to give it the same color as the walls, so room walls, this as well. Room walls. Same with these two. Okay, so there's most of it in. Here we go. This also needs doing. And I'm just going to select these stairs here. Oops, don't want that. And I'm going to give this the same color as the banister. Now I'll go into the hypershade and just gamma correct that. So I believe it's called Mere Material 8 at the moment. So stair rail. So once again we're back to adding this gamma correction node. So I'll get rid of the diffuse color, which should be this one. It is. Drop in here a gamma. Okay, and by now this should be quite obvious what needs to happen. Okay, so if we look now, you'll see our staircase has gone a lot darker. Now you could UV this so it's all the right way up, and I've actually got the railings in there too, which I did not want. So assign existing material and room walls. There we go. Now let's just take a look at this texture. And way too reflective, so reflectivity of 0.2, glossiness of 0.6. I'm going to actually turn on the ambient occlusion. Put it up to 32 samples. And distance is fine. With color bleed is on. Okay, let's look here now. We don't want anything else. No, that's perfect. So I'm going to jump back to my camera bookmark, open up my render view, and just take a quick render of where the stairs should be. Okay, so there's our stairs back. It's going to need tweaking, and I'm going to do one final part, which will be tweaking all the materials to get our final render. But for now, here is our stairs basically back in the scene. One of the other things I want to do is now shade this trim and bring the door back. So I'm going to just bring the door back by turning it on. Front door, there we go. And I'm going to create a different material for the door. So, assign a new material. And there we go. And I'm going to create a kind of gloss paint, so I'm going to go for door gloss, and I'm going to colour this pretty much white. I never like to use an absolutely pure white, so I'm going to just knock it down a touch. Okay, so the roughness is fine, the reflectivity is probably a bit too high for gloss paint, so I'm going to put that at 3. Index of refraction I'm going to leave because I'm using no transparency, and I'm also going to flick on the ambient occlusion, 32 samples and a distance of 4 with color bleed, and this should basically be our door material set. Now I'm going to assign the room color to these 3 objects here just to give a little bit of contrast. So room walls. Okay, and while I'm at it, I'll also shade this group here with the same material, so we look for door color, and okay, oh, door gloss, of course. Yeah, sorry, I just went temporarily blind there for a moment. I'm also going to use this opportunity to do these rails at the top and the bottom again in the same color. So let me just find out where they went. They're in main room, coving and skirting boards. So assign existing color, door gloss, and there's a small bit here that's actually missing, so I'm going to assign the room color to this. Okay, and now I'm going to find the shot angle that I like. Don't want so much of those stairs, but I would like to get a sort of upper view 1-point perspective, and while I remember, I'm just going to fix the gamma on this. So rename this BP for backing plate, go into the hypershade and find that material. There we go. Graph network. Now drop in that gamma correction node again, and it does get a bit annoying with all these gamma correction nodes, but it's just the way it's done. So I'm going to break this connection. I'm going to drag this into here, and again, it should be very common by now for you. Just go back in and reconnect this to the color, and I can see already that my image is now looking a lot better. I'm going to maybe drag it down a tad. There we go. I want to get the horizon line in approximately the right place, and I think that will just about do it. So that's really, every element is basically shaded in our scene now. As I said, with this sort of lighting setup, it's better to get the lighting in first, and because I didn't want this to become a materials tutorial, I've kept it as simple as possible. But I'll just do a quick render now, and I think you'll see that we have a pretty good looking scene. Okay, and here we are. So we have gone from something that looks a little bit like this to something that looks like this in fairly short order. You see our rendering time's up around 6 minutes, which is not so bad. I've got some reflections here on the skirting boards that I like. This banister needs some work. This is perhaps a bit too glossy, and our background plate here is clipped in the window. I can see it, so we'll go ahead and fix all that. But you know, as you can see, when you've got the correct lighting for physical sun and sky, shading a room, creating a scene such as this is pretty quick to do, really. So the first thing I'll fix is my backing plate here. And there you can go, I can see what's happened. It's clipped at the top of the windows. So I'm just going to scale the whole thing a little bit so we don't get that clipping. Make sure that we Yeah, still happy with this, and you can obviously move this from side to side to get a better shot reference. Like I say, this is normally something I do in post, but for the purview of this tutorial works perfectly adequately. We're going to need to create another subsurface scattering material for this doorway here. Let me just make sure that it has some thickness. I'll just center its pivot point. Okay, it does. This should be fine. What I'm going to do is just drop into the foreview here. And what I think's happened is we've got two sets, so just delete the faces here. Because I don't need a double thickness window. Actually, it'd probably be faster if I just go in this way and do it. It's just a little bit too thin. There we go. Okay, I think that's all of it. Nope, there's some left at the top. Excuse me. Okay, do we have it all? Yes, it looks fine. And this was actually done, so perfect. Go back to object mode, stick it back in the doorway. Make sure we're in there. Yep, we are. And I'm going to assign a new subsurface scattering material to this. So assign new material. And again, we'll go with the Maya Material X to set up the reflection plugin for the subsurface scattering, sorry. So we'll go here, File, open this up, and under Windows you'll see a door. So there we go. And again, for material attributes, make sure our transparency is all the way up, and plug in a color here. And I'll just use the hypershade to plug in the same color. Probably have it open. Textures, and that will be texture 9. Whoops. Back to the material. There we go. Drag it into the color here. Okay. So this should be done. I'll just go down and tell it to use those reflections. And if I just jump back to my camera bookmark, and I think we were actually a little lower. Bring up the render window, and I'll just take a quick render of this to make sure we do have a glass texture. Okay, so we have that glass texture on the door, but we want to make it a bit more like this lovely stained glass we have up here. So now that texture is applied, assign new material, subsurface scattering, and again give it the light map, go into the hypershade to make the connections. So there it is, and I'm just going to call this door glass as this, and I'll find where I put that. There we go, and call this door glass. It really does help when you're making these connections, as you probably figured out by now. Graph this network. So the first thing we want to do is go to here, make it writable, 32 bits, and our scene file size again, so 2560 by 1440, and again it's just double your scene size. So the next thing we'll do is pop out its shading group, drop in here a light map under the mental ray tab. Again, we've done this before, so I'm just doing it very quickly now. We'll drop this in. We will make sure light map writable is connected to this. Did I set this to 32 bits? Yes, I did. And we'll just now quickly drop the connections into here. So
Okay, I thought I'd actually renamed this, obviously not, I'll take care of that in a minute. So I'm going to drop this into diffuse illumination, specular illumination, then I'm going to drop it on front SS color. So diffuse, nope, front SS, back SS. Okay, nothing you haven't done before. I'm going to bump the back SSS weight up to 2. So that actually is overly illuminated, but I like to make the stained glass focal point, as I said before. You can obviously change that to your preference. So let's get a better angle on this. And render. Okay, and I think what's happened here is we have a slight issue with this geometry in the door. So I'm going to just come in and delete that and just replace it with a polyplane. And easiest way to do this is to just hide some of this room geometry. Oops, wrong button. And I'm just going to do this by eyeball. You guys can obviously take some time and get it more accurate. Let's just make this 90 exactly. There we go. And I'm going to need to just rotate this into the door frame here. Okay, and because it's having a subsurface scattering material on it, I'll also need to just extrude it a bit. So edit mesh, extrude. Okay, that should be enough. Just going to check this. It's actually got some thickness to it. Yes, it has. Okay, and then I'll reassign our door subsurface scattering material. So there we go. And let's just take a quick test render now. Okay, as you can see, I forgot to check which way up it was coming in. That's easy enough to fix. I'll just grab this. I could do it with UVs, but as it's just a square box, I'll just rotate it, get it back into position there. That looks about right. Like I say, I'll give you guys the scene file and I'll actually set this up properly. I just don't want you to watch me for ages getting this in exactly the right position. Okay, so our scene now looks a little like so. Actually, I don't have a render handy, so I'll just take another one so we can finish off this part, and in the next part we'll come back for just the final tweaks and our scene is done. See you in the next part. Actually, I'll just take the render first so we have a reference point for where we leave off. So bring our room back. Okay, so here's our render. As you can see, we still have some issues with this door plane here. I mean, there's always one. We'll come back in the last and final part and correct that. We'll also look at upping the quality of this, but I think you'll agree, so far in a very short period of time, we've matched our reference image quite well. So I will see you in the last part to sort out the quality issues, some of these shading glitches, this is too harsh. Sort out this door panel. We'll also look at bringing some of the shadows from the outside, inside, as well as putting our small pot plant back. So I'll see you in the final part. Thanks for watching. Hi, welcome back. In this part we're going to fix up some of the quality issues, and this is where we left off in the last part. We're going to fix this material on the door. The backing plate here is not bright enough. I would expect it to be brighter with the amount of light coming into the scene. Our floor here is a little fuzzy. Our UVs here are not matching up right, and I'm not totally happy with this sort of razor sharp angle we're getting on it. We're going to introduce some more overall light to the back of the scene, and we're also, if you look at our backing plate,
we have the shadows from the trees outside. Now I think it would be nice if the sun clipped the top of one of these trees as it's coming in and left a shadow pattern on the floor. So all of this we're going to sort out. I'm going to start by grabbing this texture on the balcony and getting it the right way up, because I don't want it in this horizontal, I want it in a vertical. So I'm just going to do one of these and then I'll fix the others off camera, because I'm sure you guys don't want to sit around and watch me UV for 20 minutes, and I'm going to do it in the fastest way possible. I'm actually going to drop back to no, in fact I'll leave it in viewport 2, and I have a slight issue with viewport 2 which I'll show you in just a second. So first things first, let's fix these UVs so our wood grain is going in the right way. So under polygons, create UVs, UV set editor, oh, wrong one, I want the UV texture editor of course. UV texture editor. Okay, and I'm going to flick our texture onto our wood. So you can see here with our UVs what's happening is they're going in the wrong direction. So really I'm going to fix this in a really fast and dirty way. I'm just going to flip them round, move them into position, and we're done. Now you'll see that my viewport 2 hasn't updated. Yours probably will. I think I have a slight graphics card driver issue, but it's not simple to it is simple, sorry, to fix this. I'll just assign the Lambert 1 to this and then go back and assign the stair rail material, and you can see here that my UVs are now going in the right way, and I've just basically done exactly the same thing for all of these other ones. So it's a real quick way to fix this issue, and as there's not going to be that much detail applied or seen in this wood because it's dark and our scene is not so bright at the back, I can actually get away with this. And once again this hasn't updated, so for you this probably won't be a problem, but if it is, quick and simple way to get the viewport to update is just to assign any material to it and then reassign your stair rail material, and you can see here we're going in the right direction. Now I'm going to fix the rest of that off camera because it's a pretty boring procedure to watch, and it's very simple, so I don't think you need to see me do it 12 times. So the next issue we have, if we look at our render, is that these corners are a bit sharp. So there's a couple of ways to fix this. I can re-bevel these, I can do it with geometry, but as I say, as this is not going to be a huge focal point in the scene, what I'm going to do is select our material, and under the mental ray drop down, so we'll look for that, you'll see bump here. Sorry, not under the mental ray drop down, this is obviously a mental ray material, so just under bump, and I'm going to use a standard bump which will just be this texture fed back in. So I'm going to just use the this texture, and I'm going to just feed that back into the standard bump. I'm going to give that a 0.05 because I don't need a very high bump, and that will do for the bump map. Obviously if this was more of a focal point we would be spending more time on it, and to get the rounded corners I'm going to drop back to the material and use the overall bump, which as I said before I like to save for specific mental ray nodes, and I'm going to just go here and search for MIA round corners. I'm going to throw that on. I'm going to go for a radius of 1, and we might have to tweak that, but let's just see what that's done for us. So I'll just take a snapshot of this image and I'll pause while I render this. Okay, as you can see this has knocked off our razor sharp edge here, so this rounded corners node is pretty good if you just need to do a quick rounded edge and you don't want to go through and alter your own geometry. It's a nice and simple way to do that. So there's our balcony fixed. The other areas that I wanted to talk about were to get this floor less blurry as it goes away from the camera. Now there's a number of ways to do this. I'm going to use a new filter that's in Maya 2013. So I'm just going to go up and grab the hypershade. I'm going to get our floor material. I'll just graph it to network, and I'm going to pick the floor texture, and under filter type I'm going to change it from quadratic to mipmap, and then I'm going to scroll down until I find the mental ray pull out and ARM advanced filtering here. Now an anti-alias and level of 8 will be fine for what we're doing. The higher that goes, obviously the longer you render, and this with this filter type will take a bit longer to render. But if I just show you our small region here, I think you'll see that this side is a lot blurrier now than this side, and this is, for this particular texture, I think a lot better because I like a lot of definition in this floor. It's one of the main focal points for the image. Okay, so here was the small region that we rendered, and it is a lot sharper here than it is here, and if I just do a flick backwards and forwards comparison, you can see with this advanced elliptical filtering turned on, we get a much better, sharper, more defined image further away from the camera. So in this texture, because it's such a large part of the overall image, I like to turn that on, even though it increases rendering time a little bit. Now, one of the other things was our background image here. It's too dark, and the actual photo, if you look at the texture, is much lighter. This is because this image is not receiving enough light. So a quick way to fix this, as we use just a lambert, is to grab the ambient color and jack it all the way up. And now you can see we go from this, I'll just do a snapshot, to this, and this will render out quite quickly because we're just basically rendering out the backing plate. So there we go. You can see already that it's coming in much lighter, and this I think reflects better on the overall illumination outside to inside. Okay, so that went from this to this, which as you can see is quite a dramatic change in the in the lightness of the image, and I think reflects more the colour that we would have from outside. Now there is one other thing, I think it's too dark at the back here, but we have a window here, if you'll remember. So I'm going to select the back window 1. I seem to have named this the wrong way. I'm just going to change that to side window. Okay, and if we go into the side window and we look under its portal light, so all the way down, again, portal light, you'll see we set it at the beginning of the tutorial on 0.1. I'm just going to come back and set that on 1. I'm also going to get a better camera angle. So, one I like more, shows more of the floor, and we sort of get both of these stained glass windows here in focus. And when I do a render of this now, you'll see our balcony doesn't have those sharp edges. Our UV map will be in the right place. We'll have a nice blue light, the sky obviously being blue, coming in from over here. Our overall illumination in the back will go up a little bit, and we should have fixed a lot of those small issues with the texture on the floor being not sharp enough. So I'll just bookmark this and do a complete render and see you in about 5 minutes. Okay, welcome back. Here is our image. This is what it looked like before. Now our balcony has these UVs in the right place, although I would encourage you to play around with this a bit, maybe use a different texture. If you have done any UVing in Maya before, you'll know how simple it is to fix all of these. I'm not going to make you watch me do it. As I say, it's something that's real easy to do. Just follow what I did at the start of this, or as I say, once again, if you know anything about UVs, take you a couple of minutes to fix it. But you can see here we have these overall much brighter illumination in the corner now, coming from that side window. We've also got the shadows cast from the stairs. We got a greater overall sense of illumination in the back. Bringing that extra light in got rid of a lot of this splotchiness you can see on the walls. Our background image got a lot brighter, which matches the lighting much better, I think. I still want to bring in some shadows from the outside. Our floor texture got a little clearer. Now you don't want it completely crystal clear, or at least I don't. There are ways to do that. You can turn the filtering off entirely if you'd like. Instead of using that new filtering system, you can just turn it off. This will make it a lot sharper. I think that then becomes too sharp, but I encourage you once again to play with that. In the 2 hours that we've been going through this tutorial, we've gone from a completely grey room with no lighting to a room that has almost complete control over its lighting. If we were to take our sun direction now and move it, you could turn this from late afternoon to early evening to mid-morning. All of our materials and lights will update accordingly, so you have a great degree of control from a small setup. Now, the last thing I want to go over is just bringing some of these outside shadows inside, and I'm going to cheat to do that. So I'm basically going to scroll outside here. I'm just going to create a polygon plane, just rotate it upwards like so, and you don't need to be too neat about this. Just going to get it to the sort of size I want it, so that should about do it. There we go. And basically what I'm going to do is I'm going to put a transparent silhouette of a tree on here and then shine light through it. So I'm going to assign a new material, and once again mere material X. Now under its refraction here, I'm just going to give it, let's just clear that, 2D textures, file, should have a tree brush in here. So as you can see, it's just a transparent tree silhouette. I'm going to pop that open. I'm going to then jump back to material, make sure it has a refractive index of 1 so it's not refracting, transparency of maximum. Now we also need to grab the geometry here, which I will name to tree shadow. Okay, so after I've grabbed that geometry, I'm going to go down to its render stats. I'm going to turn off receive shadows because we don't want it to actually put a shadow in the scene. It's going to cast shadows but only through the transparent material, so we're going to turn off motion blur, primary visibility, and that should do us. Now if I were to render this, because it has primary visibility turned off, and I'll just get that nice camera angle back and then bookmark it. Now because this has primary visibility turned off, you might expect it to be invisible. I mean, you certainly should expect it to be invisible, because we're working with a mental ray material. It won't be. You'll still be able to see that texture. So I'm going to show you how to fix this in just a sec. Okay, and even though you have turned the primary visibility off, you can still see here this nasty transparent tree silhouette, which obviously we do not want in our render. So if I go over to our plane here, which is acting as our tree shadow, go down to mental ray and turn off visible in transparency, you will now see that when we render this again, you won't get this. Okay, so there we go, it rendered again. It also rendered a lot quicker. Now mental ray's not having to see it, and you've got no nasty silhouette, you've just got your backing plate. But if I render this floor region out here, we should have some of these lovely shadows on the floor. Okay, now as you can see, we've brought some of these tree shadows, so sunlight hitting the top of this tree and putting this shadow here on the floor. You might want to play around with the position of the tree shadow plane there to get, you know, maybe cut them off, put them at a slightly different angle, but this is really how I did it on the final image that you see, and for me this just helps to sell the background a little bit, bringing some of these shadows in. It also breaks up this, you know, rather long light streak we've got here, and just gives people something a bit more interesting to look at. Now one of the final things that I wanted to cover was just fixing this, and I did it very simply. It's not brightly illuminated like these are, because it doesn't have any direct light hitting it, so that's actually how I wanted it. I was just going to add a bump to it so it behaves like these, which I'll do now, and these at the top could be too bright for you. For me, I quite liked it because I was trying to focus people's attention on this lovely stained glass, but if you do want to turn that down, remember you can go into the subsurface scattering material that's assigned to each of these windows and just turn down the back weight here from 2 to 0.5 to 1. Again, something I encourage you to play around with so you can get the perfect sort of stained glass for your scene. So on this door material, I literally just grabbed its material, I scrolled down to its bump map, I gave it a standard fractal bump map with a bump value of 0.1, and then I turned its transparency from 1 to 0.8 to give us a more frosted glass look on the door plane there. If you want to render out with the pot plant, again, which I think creates a nice overall dynamic, you can just go here and turn on your pot plant, so when you re-render you'll get this nice pot plant and some pot plant shadows here. It was just created simply in Paint Effects, so you might want to design something a bit different. And again, this is just for the basic overall lighting. You might want to put a hall table in or some extra elements and dimensions to this scene, and if you do, we'd love to see them on the forum. The last thing I want to discuss is just getting rid of the last of this splotchiness here on the wall and maybe improving the overall quality a little bit. So to do that, I'm just going to go into the indirect lighting and the global illumination. I'm going to turn its accuracy up to 1000. I'm going to put our point density here back to 1. I am going to up the accuracy to 300. Now I see a lot of people do this and they'll put it at some insane value like 2000 or even higher. It's not really necessary. Try and keep this as small as possible. I really don't like to have a render that goes much over 20 minutes, and if you crank this up past 500 you're going to massively add to your render time, and it's not necessary. So take a look at that. If you want to clean up some of this ambient occlusion on some of your materials, remember you can go under the material, you can scroll down to the ambient occlusion tab, which will actually be on the material. And I've actually grabbed the wrong material here. I'll use the room walls because that has ambient occlusion on it. So under ambient occlusion you could put this up to 32, tweak the distance depending on how far out you wanted your ambient occlusion to be, and when we re-render this we'll have a shot that pretty much exactly matches the reference shot that we used from this tutorial. But please remember to tweak the scene. You can definitely kick this one up a notch. We wanted to keep this tutorial around 2.5 hours, so I'll do this final render, and when we come back we'll be done. So I think in 2.5 hours to go from completely empty to fully textured, shaded and lit room is pretty good. So I will see you in about 20 minutes when our final render finishes. Okay, our final image is rendered and actually took 26 minutes on my system, which is not too bad. I'm not using a particularly fast system. Our balcony area has been sorted out now. Texture could use a bit of work, but I leave that to you. We have these nice shadows falling on the floor here from the backing plate, and I like the overall lighting of this image. We got the blue light coming in from the window over here, and these lovely sort of orange and green colours being thrown around from the subsurface scattering, and that's about it really. Just bear in mind that you can radically alter the appearance of your scene simply by tweaking this sun direction. Put a new backing plate in, you'll be able to get any time of the day you want. Alter the portal lights for the amount of light coming in from the side and the rear window, and what you end up with is a physically accurately lit scene that's taken us about 2 hours and 20 minutes in a tutorial, and should take you around half an hour to go from nothing to this complete interior light setup. So I hope that's been useful to you. I will see you in the addendum part if you're using an older version of Maya, when we'll just cover these subsurface scattering windows with older copies of Maya. Okay, any questions? Please feel free to contact me on the forum. See you in the next tutorial. Thanks for watching.